Welcome to the Tech Mechanic. Today's breakdown is part of our Azure Architecture Master Series. If you want the full roadmap, then hit the playlist from the start. With that said, let's dive into today's topic. Imagine millions of customers click, place order, at exactly 10 a.m. during a massive sale. Should every request immediately hit the payment system? Inventory? Shipping? Notifications? If everything happens at once, the entire system could collapse. So how do companies like Amazon handle millions of requests smoothly? The answer is message queues. And on Azure, one of the most powerful messaging services is Azure Service Bus. Imagine one service calling another directly. If payment becomes slow, everything behind it waits for above one to complete. One slow service blocks the entire application. This is called tight coupling. Enterprise architects avoid this. Azure Service Bus is a reliable messaging service. Instead of services talking directly, they exchange messages. The sender doesn't wait. The receiver processes the message whenever it's ready. This makes applications much more scalable and resilient. So far we've understood the concept of Azure Service Bus. Now let's see where it actually lives inside the Azure Portal and how an Azure solution architect would create and manage it. Azure Service Bus is a fully managed messaging service provided by Microsoft Azure. From here we can create and manage all our messaging resources. The first thing we create is not a queue. It's called a namespace. Think of a namespace like a container that holds multiple queues and topics. Azure Service Bus provides 3 pricing tiers. Basic supports only queues. Standard supports queues and topics. Premium provides dedicated resources, higher throughput, and advanced enterprise capabilities. Azure now deploys our messaging namespace. This is the central management page for our Service Bus namespace. This queue will temporarily store incoming order requests until another service processes them. The website sends messages. Payment service processes them one at a time. Unlike a queue, a topic allows one published message to be delivered to multiple subscribers. Each subscription receives its own copy of every message. This page generates connection strings and authentication keys used by applications to connect securely. Architects continuously monitor these metrics to ensure the messaging platform is healthy. If something goes wrong, Azure even helps diagnose common messaging issues. Everything we learned conceptually is now represented by the Azure Service Bus resource you just saw in the Azure Portal. As a solution architect, remember this simple guideline. Queue use when one service should process each message exactly once, for example, order processing. Topic use when multiple services need the same event, for example, payment success should notify inventory, shipping, email, and loyalty systems. Choosing the right messaging pattern is just as important as choosing the right Azure service. Think about sending a parcel. You don't personally wait until the receiver opens it. You simply drop it into a courier system. The courier delivers it later. Azure Service Bus works exactly like that. A queue works like a waiting line. One application sends messages. Another application processes them one by one. Each message is processed only once. Customer places an order. The order is immediately placed into the queue. Payment service picks it up when ready. The customer doesn't have to wait for every backend operation. Sometimes one message needs multiple receivers. That's where topics are used. One published message can be delivered to multiple subscribers simultaneously. Remember this simple rule. Queues are for one receiver. Topics are for many receivers. When designing cloud architectures, choosing between an Azure Service Bus queue and a topic comes down to one simple question: How many services need to read your message? Queue as a strict point-to-point delivery channel. One sender pushes a message in, and exactly one consumer pulls it out. Even if you scale out to multiple workers to balance the load, each individual message is processed exactly once. It's perfect for standard sequential tasks like processing a single payment or sending an email. Now, look at a topic. Topics use a publish-subscribe pattern. A sender publishes a message once, and Azure broadcasts a copy of that message to multiple independent subscriptions. Think of an e-commerce checkout. One order event lands in a topic, triggering the shipping team, the inventory database, and the notification engine simultaneously. Bottom line, use queues for one-to-one task execution. Use topics for one-to-many event broadcasting. Build smart, stay scalable. This is called the publish-subscribe pattern. One event. Many listeners. Each subscriber works independently. Sometimes a message cannot be processed. Instead of losing it, Azure Service Bus stores it safely in the dead letter queue. Engineers can investigate later. Imagine a payment request being sent twice. Without protection, the customer could be charged twice. Azure Service Bus supports duplicate detection to prevent this. Some business processes require messages to be processed in order. Azure Service Bus supports ordered processing using sessions. Imagine thousands of ATM transactions. Instead of directly updating the database, requests first enter a queue. This improves reliability and prevents overload. Modern enterprises connect dozens of microservices through Azure Service Bus. Each service becomes independent. Failures don't spread across the system. Notice how Azure Service Bus becomes the communication backbone. Every service works independently. The platform becomes faster, more reliable, and easier to scale. This is why architects prefer messaging. Applications become loosely coupled, more scalable, and far more resilient. Azure Service Bus isn't just another Azure service. It's the backbone of enterprise communication. Whenever applications need reliable, asynchronous messaging, Service Bus is one of the best solutions available. Whether your goal is to become a solution architect, cloud architect, AI architect, or simply a better software engineer, TheTechMechanic is your learning destination. Like this video, subscribe, and hit the bell icon to stay ahead in your tech journey.